All right, welcome everybody. This is actually the first day of our geometry notes, so I'm so excited to get started. As you can see here on my iPad screen, it is our section 1.1 notes, and this begins our essentials of geometry. So before we get into all the crazy world of geometry, all these amazing things we're going to talk about, we need to have the foundations. We need to have the essentials. So the title for this, I'm going to go ahead and highlight it for you. The title is Points, Lines, and Planes, and that begins us with our first major talking point, which these right here are called the undefined terms of geometry. There's three of them. So point, line, and plane, and I might go ahead and highlight point, line, and then down here we have plane. Those are our three that actually are undefined. So when up here you're looking at that says definition, really those are not defined, and I really need to change that to description, but then we have other terms in here that do have definitions. So I just want to first get that. We're going to start with these undefined terms and build off bigger to these foundational pieces of geometry. So the first one, like I said, is point. So for point, it is a finite space represented by a dot. It's got 0 dimensions, it's got no size, no thickness, no shape, nothing. It is just a pinpoint spot in space. And how we represent this, since we have to show it, is we represent it with a dot. And we always will label it with a capital letter. We will not use a lowercase letter. It'll always be a capital and then whatever you choose. In this case, I chose A. And as far as notation, so the notation is kind of the shorthand form for how we communicate writtenly. So again, about communication, we're working on how we're going to interact with each other, both speaking aloud and written down. So notation, you could write it as point A. Sometimes you will also see it referred to as point A written like so, or you could just see it as a capital letter A. So those three choices for notation, out loud we would say point A. Our next one here, line, and again our second undefined term. It is a one-dimensional, it is two directions going to infinity, and it contains an infinite number of points. So I'm just going to sketch one real quick for us. We got a line, and make sure that when we are sketching our lines, we will always have the arrows. We will never not put the arrows, because then we are not drawing a line, we're drawing one of our other terms we're going to talk about, which is a segment. These arrows represent we're going to infinity in both directions. And I want to point out something here too, and maybe I'll change the color. Let's go to a yellow. It says determined by 2 points. What this means is that a line contains at minimum 2 points. If there are any 2 points, we can create a line. If I were to put 2 points anywhere, and in this case, I'll call it here and here, I would be able to draw exactly one line through those 2 points. Now, that does not mean that we couldn't have any more. Actually, it's quite the opposite. It says there are an infinite number of points on that line. We just determine it, like in our picture or when we're expressing the name here in a second, with 2 points. So how would I go about naming this? Well, you got a couple options. If it were AB, I could do this. Not complete yet. We would have to put a little bar over the top, and just like in our picture, we will never forget our arrows. We will never forget our arrows with notation. The order does not matter. So instead of AB, I could also do BA. That is completely fine. Order does not matter with notation of lines. And then there's one other option, and I got to add something to my picture. Sometimes you'll see like a lowercase letter naming the line is basically what it's doing. It's labeling it. So if I wanted to use this lowercase h I just added, I could call it line H, and that is completely fine. So you have 3 different ways, really 2, just with those 2, the A, B, and BA, they're interchangeable, and then we have the line H. And I just want to add something real quick. I won't go through all the different ways to name it, but if I were to add a point, because remember, we have an infinite number of points here, and let's call it, let's call it point C. I could then name this line AC. I could name it BC. And I could switch these letters too. So I could do CA, CB with blinds. I just need any 2 points. Does not matter which order, but please remember the bar with the arrows on both. So that is line. Segment, very, very similar to line because it is just a part of a line. It has 2 endpoints. So let's go ahead and I'll sketch something actually very similar here. We have A, B, and the difference, and this is why I said we always have arrows with lines, is obviously you can see we do not have any arrows because they're not going on forever. There are these 2 endpoints and all the points in between. So we could have more points between A and B, but we just are considering A and B are endpoints when we are naming it. So very similar to what we have with the line, A, B. Bar on top, no arrows because we're not going on forever in each direction. Neither direction we have those endpoints, or I could switch it and we have BA with the bar on top of it. So line segment, just a portion of our lines. Moving on to ray. It has an initial point and then continues on in one direction. So I'm actually going to sketch eventually 2 pictures in this box. I'll start with our classic example here. I got A and then B. And by initial point, and this is where if we were in the classroom together and I'd ask out loud, which one do you think is the initial point? So if you're playing along at home, go ahead and get that guess in your mind. And if you guessed A, you're correct because our line is starting at A. It's starting at A and then going on forever in this direction. So this is going to tell us how we name it as well. So notation for this ray. I have to start with the initial point. Just like my ray starts at the initial point, my notation will start at the initial point. So this would be A, B, and then another important thing is for our bar on top, our arrow will always be pointing to the right. We will never, ever have it pointing the opposite direction. So to show you a counterexample, then I'm going to erase it. This one I'm about to write, let me do a different color, purple. BA going this way would be incorrect. We do not name it. Even though it's starting above the A and going through B, our arrow on top will always be pointing at or to the right direction. Oh, I went too far. Let me add that again. Let's get the red color back up. So I also want to show another kind of common thing that I've seen these past years teaching geometry is I'm going to add another one. Here's a ray. We got XY. And it does not matter that this ray is going to the left. We would still start with the initial point X, then Y. It's starting at X, going through Y, and we're still going to the right. So rays in real life, where do we see rays in real life? Because a lot of people can imagine a line that just goes on forever. A lot of people can imagine a line segment. We see that a lot of time, but starting point and end point. Ray, where do we see that in real life? I like to think of a flashlight. If I'm holding a flashlight in my hand and then I turn the flashlight on, it is going to start at my hand and is going to continue on. That light goes on forever in one direction. So that is a kind of a real life way you can picture a ray. Moving on, opposite rays. So this will seem very familiar. It says 2 rays with the same initial point but go on in opposite directions. So I'm going to just start by drawing one ray. And just to mix it up this time, we'll call this one C, D. And that is our one ray. And it says we got 2 rays, 2 rays that go in opposite directions. So if this one is CD, they share the same initial point, the opposite direction, so the exact opposite direction. It's not just one of those, oh, this one's going up and this one's kind of going down, but to the right. Nope, if it's going up, the other one's going exactly down. So how it would look in this is exactly in the opposite direction, and I'll call this point E. There is no special notation for opposite rays. We would just list out the 2 opposite rays. So in this case, we would say ray CD. Notice how I started with the initial point, and then we'll do the word and again, starting with initial point, so the second ray is CE. And that's how we notate it. So a little bit of shorthand and making sure that we're able to get all this down so we can communicate again with each other, whether we're writing it out, speaking out loud. So that's how we do it. This probably looks like another term we had if we were to scroll up real quick. It looks a lot like a line. opposite rays form a line. If we have two rays, and this is kind of going in the future, but if we were to have two rays that share initial point but don't go in opposite directions, we get an angle. But that's going ahead. Don't worry if I lost you there. Okay, this next one, collinear, and I'm going to actually, before we go on here, I probably need a new color anyway. I want you guys to notice, and I might have to pinch in, what it says right here, collinear, and what I underlined was line. And I did that on purpose because when we look at the definition, it says a set of points that lie on the same line. It tells us right in the term what the term means. Co-linear. When you think co, I like to think co, like co-pilot, co-worker. You are together completing a task. For this, co meaning together, points, if we're talking about collinear points, they are points that are together, and where does the line come in? It's the second part, linear. So collinear, together on a line, collinear points. Points that are together on a line, that is what we're talking about. So to get an example, we have a line, and I'm going to put a couple here. Let's throw in a H just for fun. What haven't we used? M and N. All of those would be collinear. We do not have a special notation, so we just list them out. A, H, M, N are collinear. And excuse my handwriting. Are collinear. Now there is a negation of this, I guess you could say, non-collinear, so not collinear. If I were to add a point down here, let's call it D, we would say D is not collinear with points A, H, M, and N. So collinear, non-collinear, just they're together on a line or they are not. Plane, this is our third undefined term. Plane is two-dimensional. It goes to infinity in four directions. It has no thickness, infinite number of points, determined by 3 points. So a lot there. First, let me just show you how do we sketch a plane in geometry. It looks a lot like a parallelogram. We represent it with this shape here. I got a little shaky on that. And this is a flat surface, and it goes in all four directions. It says that it is determined by 3 non-collinear points. So in our picture, if we were to make this an official plane, I would need 3 non-collinear points, which non-collinear meaning not collinear. I think I spelled collinear wrong. I'll have to fix that. We have points, let's say X, Y, and Z. Because I cannot draw one line through all 3 of those would be non-collinear. And we could name this plane, let me write this out, plane. And then our 3 points. We do not have to order them. It's kind of like a line. We don't have to order them in any way. It does not have to be alphabetical, although you'll see me do that a lot of times just because that's the way my brain works. So we could name this plane X, Y, Z. We could name it plane YZX. We could name it plane ZXY. I think you get the point. And there's one other way we can name this. Just like a line, sometimes we'll see a lowercase letter. Sometimes we'll see a capital letter. So that was my attempt at making an A. So we could name this plane also plane A. And you'll find that in the upper right-hand corner most of the time, pretty much all the time. So 2 ways we can name it. 3 non-collinear points. And also the capital letter in the top right corner. Just 2 more, and then we got some examples. So we have coplanar points, a set of points that lie on the same plane, and actually I'm just going to use the same picture here. So if we were just to say, okay, we're going to use the same thing, the set of points that lie on the same plane, coplanar, together on a plane, that would be X, I thought I was right, X, Y, and Z are coplanar. My handwriting is losing its touch. Okay, so it's very similar to collinear. We have coplanar, and then our last term here is intersection. Set of 2 or more figures. Set of points 2 or more figures have in common. So let me kind of highlight this here, or let's pick out. So I'm going to say, like, let's look at segment CD and segment. Let me get another color. ED. And if we were to say what their intersection is, what do they share? CD, ED, they share point D. So the intersection of this would be point D. maybe we have another point here. Actually, let's get a nice black color. That would be an intersection. Notation, this will take more practice and we'll work together on it. If I wanted to say a full sentence on what just happened there, I could say segment CD, remember segment CD, we would name the 2 endpoint CD with a bar over it, is intersecting, which our notation for intersect, I'm gonna put it over here, is an upside down capital U. CD is intersecting DE, or we could do ED, I'll do DE. And there's one other thing, I want to say where the intersection is at. So CD is intersecting DE, where? At point D. And we talked about earlier, we have a couple options. I'm going to name it like this. So segment CD is intersecting segment ED at point D. So that was the first part of points, lines, and plates notes. I'm going to go ahead and end this video right here, and then we're going to jump into some examples together and examples on these notes. So thank you. That was our first day, and I'll talk to you guys later.